Okay, we are with the Venkat Subramaniam, who is a consultant, author, and I understand a professor on the side as well. Very impressive. We're going to talk about languages on the JVM in Scala, Groovy, Clojure, even Java still. How, with all these choices, how do we go about choosing one of these languages for a project or a problem that we're trying to solve?
That's the real fun part, I think, is the fact that we have these choices. If we look at the past about 15 years or so, we've had an extremely compelling platform in front of us, a very powerful platform. And the real power, I've started using the word Java these days to really mean the platform more than the language itself. And the real power is in the platform, with the garbage collection and the ubiquitous library we have as well. Along the way, we've had the Java language, which really is a very incredibly powerful language as it started out with. Languages are like dogs. They tend to have a lifespan, which is in years that amounts to decades of life. Right. And so Java is an old dog. In terms of dog years or language years, if you were to look at it. So while Java is a powerful language, we have learned along the way some old things that has come back to being new in a way. And so the Java language, which started out to be a simple language, is no longer simple. And there are certain types of code we want to write. If you really think about general purpose languages, what we do is not general purpose anymore to that extent. We want to process XML. We want to do processing of various types of input, parsing those. We want to deal with concurrency. There's so much of code we want to write. And one of the problems with the Java language itself, as much as it's a really good language to begin with, is it suffers from primitive obsession. There's a lot of things we do at a very low level, and we really need to abstract out and build on top of it. And I think this is where the real benefit of these different languages on the JVM is. And what I look at, when I look at this is the real power to us, the programmers, where we have the freedom to choose these languages. But what's really interesting though is the paradox of choice. People get frightened about, oh my goodness, now I have 200 languages on the virtual machine. Which one do I choose? And in a lot of ways, it's like give an option to have a meal. You don't ask, should I choose between Pepsi and Coke and salad, right? So in a lot of ways, languages are like that. There is a group of languages from which you would select, and there is another group of languages from which you would select. So it's not, you're not selecting from n languages to do stuff. You could group these languages into multiple categories. Right. And also there's an orthogonal view of this, I think. For example, let's say I really like to program in a statically typed language. Well, I got a choice of Scala, or I could use Java, for example, because those two are statically typed. Right. But if I want a dynamically typed language, I've got a choice of Groovy, JRuby, Clojure. So if my liking is towards typing, there's a clear boundary for me to choose. In the same way, if I want to deal with DSLs, I really want to create an internal DSL. My choice would be to maybe pick between JRuby and Groovy. There's it's unlikely for me, in my opinion, that I would select Scala for that. As powerful as Scala is, its strength is not, in my opinion, in creating internal DSLs. And then the reason simply is, for a language to be useful for internal DSLs, there are two factors. One is the language must be extremely high essence and low ceremony, to use the words of Stuart Halloway. Right. I want very low ceremony. And clearly, on the low ceremony ticket, both Scala and Groovy are winners. So they both can contend. But the second reason, the thing I would look for, a property, if I want to use the word property, I would look for in a language for internal DSL, is a very powerful metaprogramming. And as much as Scala is a beautiful and great language, it doesn't have the metaprogramming capabilities like Groovy does. So if I'm going to be doing internal DSLs, Scala would not be my choice. I would be using picking and choosing between JRuby and Groovy. You could argue maybe I could use Clojure, but again, you know, from the point of view of high essence, low ceremony, reducing the noise and clarity, I would say these two languages probably comes out ahead in the context of internal DSLs, that is. On the other hand, if I really want to deal with concurrency and immutability and all those good stuff, and ability to deal with different models of concurrency, then I would say Clojure and Scala are candidates to really use in that case. Scala has a very powerful actor-based model, and Clojure also has the same thing. And they both also have options to do STMs or software transaction memories. So if my real task on hand is to deal with concurrency, I would be looking at one of these two languages. Sure, there's other languages you could use. Java itself has a very powerful concurrency API. Groovy also has APIs related to it. But again, if you ask me where it is pretty natural to do, where a language has been designed for that. And that is one of the things I want to emphasize is, when languages get designed, there's a certain set of things a language really is intended for. And languages tend to do that fairly well most of the time. But then once that part is over, when the language is trying to reach out to other things that it was not planned for, those don't seem to fit so much easily or aptly well. And so I would ask, was this language designed for it, or was it something that was added in a little later? And so the point here is that I think these are nice languages to choose from. There is a nice place to pick and choose Groovy versus Scala versus Clojure, but it's not a mix of N languages to choose from. It is really a small subset of N from which we choose from based on the type of things we are trying to do and the flavor we are looking for. And so that really brings to the point where potentially you could mix multiple languages together in a fairly decent sized application. And the goal is really not to mix the languages with the intent of mixing them, but really to be able to choose them for the real benefit they give you. The way I look at it I'm here today, and obviously to get here to this particular location, I took my car. But given the fact that 48 hours ago, I was thousands of miles away, there's no way I could have driven here in my car, so I had to come through an airplane. And maybe this evening I want to just go to the neighborhood store or to the park. I'm not going to take my car, I'm going to ride in my bicycle. And so these are different types of vehicles we have, and we mix and match them to what we do. In the same way, I think programmers have the ability to mix and match these languages that give them the agility and the power based on the type of operation they want to do. And I think it's to the great benefit of the programmers. And the goal is not to shy away from a language, but it is to really pick and choose a language that gives them the most agility for the particular problem and the task they have on their hand, I think.
Okay. So if we are going to mix languages then in a project, what kind of pressure does that put in the architecture of the language so that we can mix these without having interface problems between the different paradigms of the languages? So does this put more pressure on the architecture aspect of projects?
Right, I think that's a very good question. And one of the things we should try to avoid, the fact that these languages are interoperable doesn't mean we have to interoperate like that. Mm-hmm. I can't imagine having half the classes in Java and 25% of the classes in Scala and then other classes in Groovy or JRuby. Mm-hmm. I think that would be a nightmare to deal with. So the goal is not to mix languages like this. From an architectural point of view, I think we can probably define fairly clearly these architectural components and boundaries, and we may find out that this particular component or part of the application is really focused on, let's say, providing concurrency. Maybe this part of the application really is dealing with configurations, and this is part of the application really is processing DSLs. Right. And then we can say, aha, look at that. To service this particular component or feature or functionality, here's a language that's a better choice. So in other words, the word I want to use here is, you want to have language cohesiveness. So when you enter a particular area of code, you want that code not only to be cohesive in what it does, but also cohesive in how that's being done.
Right.
And I would look for these language cohesiveness. Oh, clearly Scala is a better choice here. Clearly Groovy or JRuby is a better choice here. And I would like to see this language cohesiveness. Then when it comes to interaction between these components or tiers, I think we have an option of a couple of different things. One hand, you could have a Java-based interface. When I say the word Java-based, I'm not talking about the Java language-based interface, but the Java-based interface as in the bytecode, if you will.
Right.
So you could have bytecode exposed interfaces, and then you could call into those interfaces. It really doesn't matter which language these interfaces were implemented in, as long as we, removing some edge case problems, we should be able to interoperate that way. That's one option on one hand. Or a better option probably is to have these things maybe interoperate through more of a data communication layer. Maybe there's an XML, or even better, something like a JSON that is being used to interoperate and exchange information. And then you don't have the language boundaries as an issue. You could really, it doesn't matter then what's on the other side to receive this. And you could pick and choose the language that best suits for what you're doing. So I would want these interaction boundaries between languages to be fairly decoupled and lightweight interaction. And then within these components and architectural boundaries to be a lot more cohesive in a language. That makes more sense to me than to say you could get into a directory and take a bet what language you're going to see is not really a good approach. So just because you can doesn't mean you should. I think that's
Right.
a clear thing to maintain.
Right, so we can couple these things together then using, say, RESTful, treating them as resources in a RESTful environment or something like that,
Right.
or even in an ESB as a service or whatever upper tier integration technology you'd want.
And leading all the way up to maybe a database interaction
Right.
or a file-based interaction, whatever that may make sense based on the application. I think that would make a lot more sense.
Okay, well, very good. Thank you very much.
Thank you for the time. Thanks.